All right, so this is over chapter 2. Now, chapter 2 is a little bit harder than chapter 1, I think, but it shouldn't be too bad. All right, so first thing is trying to find numbers in a sequence. Okay, so the first one's asking, what is the 34th term of the sequence? As you can see, the sequence, all right, goes triangle, rectangle, arrow, diamond. Triangle, rectangle, arrow, diamond. So first, what we have to do is you have to figure out how many terms are in each sequence. How many terms before it restarts? Well, it starts with a triangle, so that's 1. Then it goes to a square, that's 2. Then it goes to an arrow, that's 3. Goes to a diamond, that's 4. But then it restarts back at the triangle. So we only have 4 terms in this sequence. The next step is to take the number of terms we need. All right, it's trying to find the 34th term. Okay. We divide by however many different things are in the sequence, which is 4. Okay. This will give you 8.5. Now, what we're looking for is the whole number. Right now we're trying to find the remainder, which is this decimal, but most people don't know what the decimal is. Alright? So, what I always tell you guys to do is always take the whole number. Okay, so you're going to take this whole number, you're going to multiply however many things are in the sequence before it restarts. So that's 4 and 8. So we're going to take 8, we're going to multiply it by 4, and it gives us 32. Now we're looking at 32, so from 32 to 34, what's going to happen? So how many numbers are from 32 to 34? Well, from 32 to 34, there are 2 numbers. So that means we have a remainder of 2. So we're looking at a remainder of 2, we look at our sequence and find the second term in the sequence, which is this thing right here. So technically our answer is the rectangle. Alright, next one, LMFAO. So once again, let's count. 1, 2, 3, 4, 5. And since it starts at L again, we only have 5 terms in the sequence. We take the number of terms we want, 54. We divide it by 5. That will give us 10.8. Okay? We take the whole number, which is 10. We multiply it by this number. So we take 5 times 10 to give us 50. And since from 50 to 54 is 4 numbers, we're going to look for the 4th term, which is A. And we're going to give the letter A as our answer. Now the next one, counterexamples. All right, it means what is something that proves this statement wrong. So the first one's asking the sum of 2 odd integers is odd. Well, it's pretty easy to prove wrong because honestly, if you choose any 2 odd integers, it doesn't matter which ones you use, you'll notice that it always gives you an even number. Now, so that one was easy to kind of prove wrong because this is a counterexample right here. This tells me that I just add 2 integers together. It gives me an even number, which proves this wrong. So there you go. This statement is false. The next one's kind of a little bit harder. The product of 2 numbers is always greater than their sum. So what that means is the product, meaning multiplication, is always greater than when you add the numbers together. So like if you chose any 2 numbers, let's say 4 and 5, right? 4 times 5 gives you 20. 4 plus 5 gives you 9. All right, right there, that essentially tells you that, well, this has some truth to it. But we got to find something that's going to prove this wrong. If you go to really any high numbers, it's not going to help. So what you guys should have thought of is like, okay, so what's the simplest one I can think of? And a lot of you guys started thinking, okay, so 1 times 1. 1 times 1 is the easiest multiplication problem anyone can think of. Because 1 times 1 equals 1. All right? But let's say we take the sum, 1 plus 1. Okay? So 1 plus 1. That gives you 2. All right? So the product is not bigger than the sum. So in this instance, this is not bigger than this. So this proves that this statement is false. So this would be our counterexample for this one. All right. Now to get back into conditional statements. All right. Conditional statements are your if-then statements. So remember this. If-then statements. If it's something, then blank. All right. Right now it says bananas are fruits. So we can say something like this. If it's a banana. If it's a banana, then what? Well, then it has to be a fruit. So that is our statement. I know it's kind of simple, but that's all we needed. All we needed is make an if-then statement. If it's a banana, then it's fruit. Then it gets to the hypothesis. All right. So conditional statement is made up of two little things. You have the hypothesis, which is everything that follows the if, and the conclusion, which is everything that follows the then. So our hypothesis in this case is it's a banana. It's a banana. Now our conclusion would be it is a fruit. Alright. Now the converse. Converse. Alright, the converse, what it does is it looks at the conditional statement. Conditional statement, remember, is broken up into the hypothesis and conclusion. Well, the converse, what that does is it flips around the hypothesis and conclusion. So instead of starting the sentence off as it is a banana, it is a banana, we started out if it is a fruit. Okay? If it is a fruit, then what? Well, since the other one's talking about bananas, we'd say then it is a banana. Now, the statement, as you can see, is false because not saying that if it's a fruit, then it has to be a banana doesn't make sense. You could have said something like an apple, anything like that, but I'm not asking for true and false. I would just say, just know that that is false. The inverse. Okay, so now, the inverse. We look at the original conditional statement. It is a banana, then it is a fruit. When we look at that, what we're trying to do with the inverse is make that statement negative. So instead of saying if it is a banana, we say if it isn't a banana. If it isn't a banana, then what? Well, then it isn't a fruit. So if it isn't a banana, then it isn't a fruit. That tells me if it isn't a banana, then it couldn't possibly be a fruit. Well, once again, that's a false statement, but all I wanted you to do was to write that down. Finally, the contrapositive. The contrapositive flips the inverse around. So just like the converse flipped the conditional statement around, the contrapositive flips the inverse around. So instead of saying if it's a banana, then it isn't a fruit, we say if it isn't a fruit, then it isn't a banana. Alright, I'm going to do one more of these and then I'm going to move on from these conditional statements. Or at least that part of the conditional statement. Alright, apes have no tails. Alright, so once again, a conditional statement. If something, then something. Well, we say if it is an ape, then it doesn't have a tail. So if it isn't an ape, then it doesn't have a tail. Simple, clean. Hypothesis. Always think it follows the if statement, so it is an ape. Conclusions always follows the then. It doesn't have a tail. Okay? Converse. Converse, well, all you have to do there is flip around the conditional statement. So instead of saying if it's ape and it doesn't have a tail, we say if it doesn't have a tail, then it isn't, or it is an ape. My bad. Alright, so if it doesn't have a tail, then it is an ape. That is wrong because, I don't know, it's something that I don't have a tail, but I'm not an ape. I don't know. Something else that doesn't have a tail. Can't think of anything right now, but whatever. I don't know, a ball doesn't have a tail, but it's not an ape. Something like that. Just to let you know, it's just converses are usually false for the most part, unless we get to biconditional statements, which we'll talk about here in a sec. But no, converse is usually false. Inverse. Okay, so now we go back to the conditional statement, we make it negative. If it isn't an ape. Alright, now this next part. Then it doesn't have a tail is the original conditional statement. Now when I say make something negative, if it's already negative, just like in math, when you make it negative again, it becomes a positive. So instead of saying it doesn't have a tail, we write it does have a tail. Contrapositive, once again we flip that around. If it does have a tail, then it isn't an ape. Alright. Now I'm not going to do the third one because that should be good enough on trying out the conditional statements. Alright, the next part, because we're also going to do more in the biconditional part. Biconditional statements. Alright, so biconditional statements can only be written if both the conditional statement and the converse are both true. If they're both true, then they can be written as an if and only if statement, meaning the biconditional statement. Find the conditional statement and converse of the following. If both are true, then write the biconditional. First, circles are round. We write something like this. If it is a circle, then it is round. So if it is a circle, then it is round. Okay, but pretty basic, straightforward. That is the conditional statement. Now, converse is to flip that around. So we'd say, if it is round, then it is a circle. Alright, so now we got to tell whether or not both the conditional and the converse are true. Well, in this instance, the conditional statement is true. If it's a circle, then it's round. Well, duh. If it's a circle, it's round. All circles are round. That makes sense. Now, the next part, the converse. If it's round, then it's a circle. Well, I mean, there's a lot of things that are round. Balls. Actually, that's all I can really think of, but still. Balls would be a counterexample of this. A ball is a sphere, and it is not a circle. So therefore, there is no biconditional to this. Not both the converse and the conditional statement are true. So since they aren't both true, there is no biconditional. Next one. Quadrilaterals have exactly four sides. Well, just to let you know what a quadrilateral is a four-sided figure. So I can pretty much tell you this one's going to be good. So if it is a quadrilateral, then it has exactly four sides. Alright, that's true. Put true there. Let's flip it around. If it has exactly 4 sides, then it is a quadrilateral. Alright. So that is also true, since all 4-sided figures are quadrilaterals and all quadrilaterals are 4-sided figures. So since those are both true, we can write our biconditional. So how we write biconditionals is an if and only if statement. I always start off with just saying the first part of this. We're essentially going to dissect this in half. Quadrilaterals and have 4 sides. Those are our 2 little subject areas that we're talking about. One is talking about quadrilaterals, the other one's talking about having exactly 4 sides. So in between that line, we're going to write a if and only if statement. So we're going to start with something like this. It is a quadrilateral if and only if it has exactly 4 sides. Okay? So, that is how you write a biconditional statement, is you always put if and only if. Now, this next one, I'm just going to save the hassle. This is also true. Okay? So, the conditional statement would be, if it is an acute angle, then it's under 90 degrees, and then the other one will be, if it's under 90 degrees, it is acute angle. That is true once again. So if I were to write this as a biconditional statement, I cut this in half. Acute angles and under 90 degrees are 2 different ideas. So I'm going to cut that in half and then write it like this. It is an acute angle if and only if it is under 90 degrees. Pretty easy. Alright, next part is using the law of detachment. Now, remember, the law of detachment, essentially the idea is that we have one statement, an if-then statement. If x equals 5, then 2x minus x equals 4. What we're looking at is actually at the second statement and seeing what part of this statement of statement 1 does statement 2 agree with. Does it agree with the if part or the then part? So statement 2 says x equals 5. Well, it's pretty easy to state that if x equals 5, that's agreeing with the if part, since the if part of this statement is if x equals 5. So notice how these match. Now, if it matches the hypothesis or the first part of the if-then statement, our conclusion is whatever has been concluded already for us, which is then 2x minus 6 equals 4. That would be our conclusion. We concluded that if x equals 5, then, well, obviously 2x minus 6 has to equal 4. But but the next one, where they say, if you build it, then they will come, they came, all right? They're saying if you build it, then they will come. Well, they came. Do we know that we built anything? No, we just know they came. So, since this only agrees with the conclusion, and only agrees with the conclusion, there's nothing after this. There's no conclusion to this conclusion, meaning there's nothing to draw an idea on. We don't know then that if they came, what would happen next. So since we don't know what would happen next, we would say there is no conclusion. We don't know what's going on. We know they came, we don't know why they came, but we don't know what's going to happen next. You're always seeing, if it has a right here, we know what happens next because it's right here. It goes from here to here, but we don't know what comes after they will come. Now, when you're using the law of syllogism, all right, this gives you 2 if-then statements. So like, if you give a man a fish, then you'll feed him for a day. You feed him for a day, then you'll make a new friend. Okay? So, we got to use our thought process. If you give a man a fish, then you'll feed him for a day. Now that you've fed him for a day, then obviously you're going to be making a new friend. So, what we can say is that if we just cross this out, alright, this statement still makes sense. If you give a man a fish, then the conclusion will have to be you made the new friend. Alright? So, what we have to do is whenever we have the law of syllogism, we check for, alright, an if and a then statement that say the same thing. If we have an if and a then statement that say the same thing, we can cross those out, and our conclusion becomes the first part of the if and then the then. So if you give a man a fish, then he'll make a new friend. That's all you'd have to write. Alright, so you write this and then you write this. This one right here. If you are nice to your neighbors, then they will give you cake. If they give you cake, then you'll get fat. Well, once again, we can cross out these two parts. I know this doesn't really make sense, but in math, for some reason, it does. So if you're nice to your neighbor, then you'll get fat. Don't take that actually as law. That's not actually true, but in this instance, it is. So we cross out the middleman, and we're left over with if you are nice to your neighbor, then you'll get fat. All right, last page. All right, this kind of goes with the last part. All right. It's stating that if AB equals CD and CD equals EF, then we can conclude that AB equals blank. Well, we know that AB equals CD, and we know that CD equals EF. So we can actually conclude by cutting out CD, all right, just like we did before, that AB actually does also equal EF. Since they're all the same length, all right, it's easy to conclude that AB equals EF. It's like stating if a basketball weighs the same as a soccer ball, and a soccer ball weighs the same as, I don't know, a beach or a volleyball, then you can conclude that a soccer ball and a volleyball weigh the same, since the middleman, the basketball, weighs the same as both the soccer ball and volleyball. Same thing here. We have x equals y minus 5, and y minus 5 equals 9. Okay? So we can conclude that that x actually equals 9. Now this next one is we're going to use the two ideas, supplementary angles and vertical angles. Now remember, vertical angles are created when two straight lines cross each other, and they're the angles that are crossing each other. So there's some easy ones we can figure out. Angle 2. Well, angle 2 is created by these two lines, and since these two lines also create 54, we can tell that since these two are across from each other, that they must equal each other. So angle 2 would have to be 54. Now angle 4, once again, it's created by these two lines, so it has to be the same as the one that's created by 32. So the answer would be 32 here. Now angle 1 and angle 3, we don't know what those are. We know that they're equal, but we don't know what they are. So we got to think about this. How much does one straight line equal? Well, a straight line is 180 degrees. So we know that straight line is 180 degrees. And we know that these three angles right here create the straight line. All right? So these three angles here create this straight line right here. Well, we know this one's 32. We know this one's 54. And we know that angle 1, when added to it, would make the whole thing equal 180. Well, if we combine these two together, which will give you 86, and then we subtract 86 from both sides, we should be able to tell that angle 1 equals 94 degrees. So now we know that angle 1 is 94. We can tell that its vertical angle, which is this angle 3, is also 94. Now remember, vertical angle does not mean it's angles that are up and down from each other. It's just angles that are across from each other. Alright, last part. Okay, so once again, we got to use some of our ideas. First, let's find this blank angle because that's going to help us out in the long run. So this, you have a straight line, you have this angle which is 124, we're trying to figure out this missing angle. Obviously we can do that by taking 180, which is the measurement of the straight line, subtracting the part that we know, which is 124, and getting the part we don't know, which is 56. So technically this is 56. And we're using the ideas of vertical angles again because, once again, if something's across from each other, they're vertical angles and they're equal. So we can solve for y by setting this equal to 56. Add 4, 3y equals 60. Divide by 3, divide by 3, y equals 20. Alright, wrote the first part. Now let's get the second part. We know that 5x minus 1 should equal its counterpart, which is 124. We solve. 5x equals 125. We divide by 5, and we get x equals 25. Alright, so x is 25, y is 20. Well, let's do the last one. Alright, so once again, let's figure out this other angle before we move on. So we know that that this angle is 180. We know that part of it is 100, so we tract 100 away. We'll get 80 degrees is the missing angle. Now we know that missing angle, we can solve for x and we can solve for y. So we know 5y equals its counterpart, which is 80. And we know that 4x plus 8 equals its counterpart, which is 100. So let's solve for y. Divide by 5, divide by 5, y equals 16. This other one, subtract 8, 4x equals 92, divide by 4, divide by 4, x equals 23. Alright, so those are all my reviews. If you need help, just let me know in class or right before the final. But beyond that, good luck in the final if you're watching this to study. Otherwise, hopefully, whatever. All right, have a great day.